Welcome back, viewers, to episode 5 of Expert Panel Discussion brought to you by ScienceOverse, a podcast where we bring experts from various scientific disciplines and ask about and discuss about their work. In case you are new to this channel, go check out our other episodes of ScienceOverse Expert Panel Discussion on this channel and do follow us on Instagram for new updates. Without further ado, let's get started with our session. I am your host, Anirban, coordinator of Astronomy Department, ScienceOverse, and today we have a very special guest. Today we have with us Dr. R. Venkatesan. He is currently working as a professor of practice at Anna University and adjunct professor of University of Massachusetts. He is also a member of committees of Government of Tamil Nadu and Kerala. He served as a consultant at UNESCO Paris. He also represented India in World Meteorological Organization, Switzerland. Welcome, sir. Welcome to this podcast. Thanks for joining us. Please introduce yourself and tell us about what you do.
Thank you very much. At the outset, I thank Science for giving me this opportunity. And thanks to the readers for joining us and interacting with us in this particular session. I would like to introduce myself. I have about 42 years of service in ocean science and technology, worked in National Institute of Ocean Technology. I was responsible for installing the ocean observation system at sea, which provide real-time data from the ocean for early warning and various scientific application understanding about the ocean. So here I would like to share my experience and today what we are and what the ocean plays a major role. We'll be discussing more about that on this session. Thank you.
That's great, sir. So, without any further ado, I should proceed with our questions for today. So, first thing that I would like to ask is that why is studying the ocean crucial for understanding global climate systems? Or in general, why is it necessary to study ocean?
Very important question. We know very well that 70% of the earth is covered by the ocean. And I would simply put it in such a way that the water what we drink, the air what we breathe, and the temperature what we have on earth too is all because of the ocean what you've got. And in particular to the climate change, the ocean plays a major role on absorbing the heat. 90% of the extra heat liberated into the atmosphere is absorbed by the ocean. And the carbon dioxide, if you look at it, 30% equivalent almost like a transport sector from the fossil fuels, that has been absorbed by the ocean. That's got a tiny phytoplankton. This plankton absorb this. In addition to that, ocean is also providing water for us for the rain on the land. So when you talk about climate change, which is a long-term effect, we need to understand about the ocean. We need to look at it. And also we need to see what changes are taking place and whether the policy decision by the an international level or the national level is getting affected. So for all these things we need to understand about the ocean, to understand about the past, present, and to predict the future.
I see. Sir, recently I have heard about the things that the ocean has a certain, systems like ocean current systems all across, the planet. So due to the present changes in average global temperature, this system is getting disrupted and it's causing some issues. So can you discuss some of these issues, like what is happening?
The ocean dynamics are so complex. So when you talk about the currents, it sounds not the surface current, not only surface current, we call it as a upwelling phenomena from the bottom to the surface, surface back to the bottom, and global current, that's we call it as a global conveyor belt, where the water is moving around from one part of the ocean to the other. So the whole ocean is connected. So even some of the activity what you got is linked to the polar region, Arctic and Antarctic. So the heat transport from the tropical where we live in, particularly from the equator region, this heat is transported to the polar region and the cold here, the colder temperature is brought in back to that. So these current system, whatever we have got, it's having a wider role to play. I think what you're referring to, that one of the important finding in Atlantic Ocean that's being talked about, that is being really discussed in a larger level. And coming back to the Indian Ocean temperature has risen about zero point 0.5 degree. That's what we are talking. When you talk about the Indian Ocean, the average temperature is 3,000 meter. We have the deepest waters close to the 6,000 meter. You can imagine the quantum of water what you got, and about 25 plus nations living along the coast. So this is so unique, and the current system really playing a major role. And in addition to that, we should know, and this for mainly for the students to know, that in our waters, particularly in West Bay of Bengal and Arabian Sea, east and west coast, we have unique current system that is changing the direction in the East India coastal current. Nowhere in the world the current direction changes. Then you can imagine what complexity we are talking about that. And the whole system is working in such a way that it makes us to live peacefully. It makes us to provide a conducive environment to live in. So any changes, disturbances, what is happening, the health of the ocean is really important. Here, I would like to present you an important thing what all the member countries have joined together. And the United Nations has declared 2021 to 2030 as a UN Decade of Ocean. That is for the Ocean for Sustainable Development. That is what is a prominence they are providing. They are having many activities to bring in awareness so that the healthy ocean is important for us for a better living of current and the future generation.
So you mentioned that the average temperature of Indian Ocean is rising by zero point 0.5 degrees Celsius.
Degrees centigrade. Yeah, yeah,
Yeah.
yeah, yeah.
So, a lot of people might think that zero point 0.5 degrees is not that much, So,
Yeah.
uh, what sort of
That's
difference
the
would it make
reason.
about
Yeah, that's the
0.5
reason I
degrees?
mentioned about. Yeah, that's the reason I mentioned about depth. What you are
Okay.
talking is quantum of water. You look at the small vessel what you got at home when you boil it, how much time it takes for it to boil. When you look at the ocean, so large, an average temperature is 3,000 meter. That is what is alarming for us to think about that. And when this temperature is rising means really, that's what we call to something the marine heat wave. You must have heard about the marine heat wave. Today, what we are finding is heavy downpour. Even though average rainfall remains same, the heavy downpour, 2 to 3 days continuous rain, you must have felt it in Bombay and other region, like in Wayanad, what has happened. This is what is the changes linked to the what is happening into the ocean or the warming up of the ocean. One of the reason, there could be many other reason. One of the reason is that's what is alarming for us. In addition to that, since you raised an important point, I'm bringing back to the importance of Bay of Bengal. Bay of Bengal is next to Amazon, having a large amount of fresh water. Ganges, Brahmaputra, Irrawaddy rivers bring large amount of fresh water. What happens to the fresh water is ocean has got salinity. The salinity gets changed. Salinity is about 36, 30, 38, we call it. In the region close to Calcutta, in that waters, it can drop down to 26 and 28. We had an interesting study by India and US. For 5 years, we have used special tools to study this phenomena because, like you can remember, layer by layer, you have a different density of water. You remember, you must be having a juice in the cup. You'll have a juice where top is ice and bottom one color and lost. So similar like that. That is mainly because density. Heavier one it goes down and the lighter one goes up. You can imagine in the Bay of Bengal you have a stratification. Now next thing is about sunlight. Sunlight is an important energy for us to live in. The sunlight has to penetrate into the ocean. This penetration of the sunlight is affected in Bay of Bengal because of the stratification. Today, we have got a fixed monsoon cycle in Arabian Sea. In the case of Bay of Bengal, today even in Chennai, it's raining mainly because of this stratification, raising to low pressure, the having the wind formation and coming over there. So what I'm trying to bring out the thing is that we are having a complexity already. In addition to that, we have a climate change and anthropogenic effect. So that is what is making it more complex for us to face these challenges, and really ocean need to be understood more scientific knowledge is required, and more action to be taken in such a way that we have a healthy ocean for us to live in.
Okay, sir. So, yeah, kind of interesting. Never thought about that. The salinity level can be, deposited layer by layer due to the difference in density. Although it
We
is a
call this a
very,
lens.
mundane thing, if we think of it, we experience this kind of thing every day. So my one more thing that I would like to ask you is that uh, it's I live near Kolkata. Okay, so it's a coastal city of Bay of Bengal, and it's my personal experience is that the frequency of these cyclones that come every year, the frequency has somehow increased. I don't know if it's only me who is, thinking of this or not. So, is it in some way linked to the, warming up of these oceans?
Yeah, a very interesting question. The cyclone is 4 times more in Bay of Bengal compared to Arabian Sea. Is 1:4. This
Okay.
is from 1970s. We have records, and what you are talking is another challenge. What we are facing now is you would have noticed. Now even we have published work on is 2020, 2021, and 2023 back-to-back cyclone. You have in Bay of Bengal, you have in Arabian Sea. This has
Yes.
never happened earlier. This type of frequency. So well, these are all mainly because the challenges like one could be marine heat wave or the climate change or warming up of the polar region. So it's all the complexity what we are facing is that is what science has to look into in a broader perspective. It is not one phenomena alone. The complexity is being faced into that. I will also put you another important point. We have three major oceans: Atlantic, Pacific, and Indian Ocean. What is the difference in Indian Ocean? Don't say that India has got Indian Ocean into that. Indian Ocean is the only place where the land mass of Indian subcontinent is subtracting from two polar regions. So connecting Arctic and Antarctic is happening in Atlantic. It's there in Pacific, not in Indian Ocean. That's the reason this land effect is really making the monsoon to come. You would have wondered how this monsoon is starting exactly in the month of June and coming back up to the September, October, goes down to the Himalayas, coming again back to Bay of Bengal. This is unique phenomena. The monsoon word cropped up only in our region. Now we have got many other places. The main monsoon came, the name came from our region. That's mainly because of the heat wave coming from the Somali region, heading towards that. And that is leading to the moisture coming into that and the rainfalls. So we have to see many other aspects. One more aspect is Coriolis effect. Earth is always rotating. I spoke about dynamics of the ocean. You asked about current. You also have to add another phenomena is Earth is rotating. Coriolis effect also there. So you have to look at all these aspects. That is what we are studying in models. We are working on supercomputers. India is well equipped, one among the four big nations to have supercomputing facility in Ministry of Earth Sciences. So our understanding is improving day by day, but still we need to put more efforts to do that.
Yeah. So can you explain the last part, please? I got interrupted.
Yeah, fine. I will explain to you again. The last part is related to how our understanding about the ocean and atmospheric interface. The very important thing is that ocean and atmosphere has to link together. There is exchange of heat between these two that need to be understood. That is what is making all these things. So for understanding this, we need to have the computation facility. We need to have models to run. And we have got Earth system approach. This is a new phenomena, which I was also part of a committee in World Meteorological Organization. You have atmosphere. All these days, weather prediction is only by atmosphere. But now the new thinking has come. It's not Earth is comprising of atmosphere, ocean, cryo, as well as space and hydro. All these things are linked to that. So now we started. I'm slightly making it more complex. I've already told you complexity of the ocean. In addition to that, if you make this more complex, how do you do all these things? It's by mathematical calculation. Mathematical calculation, you all would have studied in mathematics. differential equation. So everything what I'm telling has to be brought in an equation. That equation to be solved, and that is by collecting data, running the model. I have simplified it. So globally, scientists are working. The data sets come from different source. One from the ocean, one from the satellite, even the aircraft, what you fly, collect data and provide to us. So whatever you are talking today has got multiplicity of data set in different sources coming together to run the model. That is what the science is helping us now.
Okay. Uh, so apart from the ocean warming up, since the Industrial Revolution, we have been consistently dumping carbon dioxide into the atmosphere at an alarming rate. And since the ocean absorbs, almost everything, so the ocean has been acidified a lot, in past over the past centuries. So, can you explain the role of oceans in carbon sequestration and their impact on global warming?
Yeah, a carbon sequestration ocean really plays a major role, as you rightly said that the major amount of carbon dioxide is absorbed in the ocean. If you look at the coastal region, the habitats like seagrass and mangroves, they can take carbon dioxide 4 times more than the terrestrial forest. That's the level of capacity they have got into the ocean. Now, what happens to this carbon dioxide when it keeps absorbing? Can this continue to do that? That is what you rightly mentioned about acidification. This carbon dioxide gets into the carbonic acid and changes the pH of the ocean. You all must have studied about pH,
Yes.
and the pH is from acidic to yeah. So the ocean, because of the carbon dioxide absorption, it becomes more acidic. Now the question can come, if it is more acidic or acidification, it's not like acid we are talking, so changes in the pH level that can affect marine organisms. You would have heard about crabs, you would have seen about lobster. They all have got a shell we call carapace, and these formation of the shells, and that gets affected when the pH level changes. Not so this whatever we are talking about acidification has got effect on the marine organism, and there is a carrying capacity up to which we can do. Other side, when you talk about climate change, today we 1.5 degrees centigrade from the industrial era we are talking, it has gone to 2. In addition, whatever we are stopping today, it has to get absorbed, or whatever is there in the atmosphere, it has to taken back. So what scientists and policymakers are looking is ocean is an option. What you mentioned about carbon sequestration is the can you take this carbon dioxide from the a cement plant or a power plant, take into the deep ocean and store it for the larger period? This is one side. Then ocean fertilization is another aspect by which the phytoplankton effect, whatever the that can be improved, but it has got its own challenges and limitations. One is scientific acceptability, because we are disturbing the biogeochemical cycle. Many things are happening in the ocean. We call it as a cycle. By introducing such a thing, are we disturbing the cycle? Are we allowed to do that? Or we allow the nature to readjust themselves? So there's no concrete decision has been taken unless the long-term effect of such carbon sequestration enhancement is proven. But scientists do keep working on it, trying to understand about that. But currently, the public acceptability and the scientific acceptability in the broader perspective is not come to the conclusion. But the research work is being done in the larger level. How much it can absorb, whether you can do the electrochemical process by which carbon dioxide can be taken. Can you take this sequestration to the distributed to the larger ocean? Because now it may be happening close to the ocean, or can we take it to the open ocean, far away region? So these are all some larger level thinking we are working on it. This is what on a climate change part I can tell about on sequestration. Thank you.
Uh, if we are talking about dumping, carbon, our carbon waste to the ocean or distributing it, so wouldn't it create more problems than it is
Yes,
already
sure.
creating?
Correct. That's what I said, acceptability.
Yeah.
That is what. long-term effect is not known. Only research papers are being published, small work has been, even I attended an international seminar, this has been talked about it in Germany and US, but it is not acceptable at all at this stage, unless long-term effect. So
Okay.
whether the nature itself can get corrected, or are we right enough to do something disturbance to the nature? This is still a big question mark.
Yes, so for now we are seeing alarming number of coral deprivations, like the corals are getting bleached, and all the systems, all the ecosystems that corals support, they are getting destroyed. So although we cannot see it directly happening, most of us are not bothered about what is happening in the ocean and what is happening to the coral ecosystem. But how would the change in coral ecosystem due to this coral bleaching affect us directly or indirectly?
Yeah, very important point. Uh, I will just extend it. India, being a tropical country, we are uniquely placed to have whatever ecosystem you spoke about it. We have a coral ecosystem, we have seagrass ecosystem, we have mangrove ecosystem. Anything in the world, the ocean related ecosystem, we are blessed to have all these ecosystems. Now, when you talk about the coral ecosystem, as you rightly said, more than 3,000 marine species are housed within the ecosystem. It's so sensitive. Coral has got a polyp, which is having a plant and animal symbiotic effect. It converts by photosynthetic effect from the sunlight. That energy is passed on to that. This is what human you have to learn, how the nature has provided a plant and animal to live together. But when you look at this ecosystem, they are sensitive for temperature. The temperature rises, they get bleached. Or anthropogenic effect, if you get into more amount of discharge or sedimentation getting into that, then it gets affected. We have seen it in the past. That's the reason the government of India is having, or the global level, we are part of a larger level work group on developing a management plan. We have got our own strategy to do that in protection of these. That's being effectively done. Good amount of monitoring is happening by the Ministry of Environment, Forest and Climate Change. So we are trying to work on it in protecting, particularly bringing an awareness to the people living over there. And it has got other side. The people have to be supported also for their livelihood. That's also being taken care by in a comprehensive way in this type of policy.
Okay. So, sir, as of now, we were talking about different, ocean systems and how climate change is affecting those systems. So all this comes down to our ability to study ocean. So currently we have satellite technologies and other advanced technologies to study, even space frontiers and everything. So, how do you think satellites and ocean robots transformed our ability to monitor and study oceans?
Very interesting question. The invention of satellite has revolutionized our understanding, because satellite is the only source to have a spatial coverage. Means global coverage of the ocean, global monitoring is possible by having this satellite. India is proud to have a large amount of remote sensing satellite launched in the space to understand both about the land and the ocean. In the NASA satellites, we have got both geostationary satellite or polar orbiting satellites. These satellites provides sea surface temperature, phytoplankton for the fisheries purpose, sea level rise, and also melting by in the inaccessible region like polar region, Arctic and Antarctic, sea ice coverage that is being monitored only by satellite. It's not possible by any other way. And in addition to that, topography, like whatever changes is happening on the seabed, that contour can be seen in the ocean. So that advancement of the sensor, the development of ability to have this satellite far away, 35,000 kilometer away, and having this global coverage and providing this information is really important. Coming back to the societal application, Minister of Environment Sciences under the INCOIS, International Center for Ocean Information Services in Hyderabad, they are providing potential fishery zone where the fishermen can go and do the fishing by having the satellite data and providing early warning. They are also having the coral bleach warning from the satellite data. So the satellite data application for the society in the ocean related, not only for the research publications, for the product level is really advancing. Even the space applications under Ahmedabad, they are also doing wonderful services in this regard. Now, coming back to the ocean robots, the advancement of technology in the ocean sector, particularly robotics technology, has really improved a lot in these days. Earlier, we used to have my own olden days, about 1980s, we were depending on ships. We go in the ship and collect data. Now, the ocean doesn't wait for the ship to come. It is happening continuously. So unless you have a robot which is unattended and deployed at sea, it is not possible for us to collect. Now, whatever you are talking about satellite, it has got its own limitation. The electromagnetic radiation cannot penetrate more than 1 meter approximately. So, how do you do below that? Only having these robots deployed. The robots could be fixed in one location. Robots could be profiling or moving up and down. These are all different type of robots you've got. There is something called Argo floats. This is a profiling float which can dive down up to 2000-meter water depth and parks in that depth for 3 to 4 days, pops up to the surface, transmit data, again dives down. So these type of Argo floats can remain for a period of 3 to 4 years. Now, last almost 18 years now, these Argo floats you can see has really improved us to understand about El Nino and La Nina. Today, what we are talking, what is happening, that major understanding has come from the Argo floats. Now, India, if you look at it, we launched the ocean observation by having the remotely located devices way back in 1997. Today, we are much improved. We have got unattended system deployed at sea. We have the ability and expertise to do that. And we do have ships to deploy the systems because making the system functional at sea is really tough. You have to have a robust system. The system can be approached only once in a year, and we need to have a battery charging ability. And we are advancing in such a way this type of technology in the engineering aspects and the sensor technology. How do you sense the ocean? When you spoke about zero point 0.5 degree, the sensor which is measuring is 0.001, 3 naught and 1. That is the level of accuracy you should have. Then only we can predict. You can, and also when you talk about 1 year, the sensor should not malfunction. Sensor should be able to, and we also call drift. One particular location today you are measuring 28.2. Same location next year, same month, same date, it should measure give 28.2. It cannot give 30, 32. That shows the instrument is drifting. Drifting means changing its phenomena because basically they are all electronics. But here we have got sensors which can have a drift of less than 4%. That's the level of accuracy we are talking. That's the reason ocean sensors are expensive to maintain, deploy. You need expertise to do that. Very complex. But we have succeeded and we are doing very well in that regard. Happy to say that the whole team is in India, engineers, technicians, scientists, we are all comprehensively working together to make the system functional.
Okay. So, sir, as we're talking about the robots and ocean rovers, so these robots, they communicate with us in real time, or do they store the data and we go and collect it?
Yeah, very good question. It is collecting data and communicating in real time, particularly the one where National Ocean Technology is deployed once in 3 hours.
Okay.
The data comes once in 3 hours, more than about 100 parameters. I can tell you about wind speed, wind direction, air temperature, air pressure, and subsurface temperature, current, up to 500-meter temperature and salinity. Wave, we have recorded the largest, highest wave during 2021 cyclone. And all these things are possible and by providing real-time data through satellite.
Okay.